All right, so we are going to continue with lesson 5.6, properties of special parallelograms. So we have lots of conjectures that we talked about in 5.6. One was the double-edged straight-edge conjecture. So if two parallel lines are intersected by a second pair of parallel lines that are the same distance apart as the first pair of parallel lines, then the parallelogram formed is a rhombus. So if you take a straight edge, a double straight edge, you draw two parallel lines and then you flip it diagonally and draw two more parallel lines. Obviously, because you're using the same straight edge, the lines are going to be equidistant apart. So now you've created a rhombus. From the rhombus, we have a couple of conjectures. The rhombus diagonal conjecture says the diagonals of a rhombus are perpendicular and bisect each other. And rhombus angles conjecture. The diagonals of a rhombus bisect the angles of the rhombus. The rectangle diagonal conjecture says that the diagonals of a rectangle are congruent and bisect each other. And then the square diagonals conjecture. The diagonals of a square, not a square, of a square, are perpendicular, congruent, and bisect each other. Of course, because a square is both a rhombus for congruent sides and a rectangle for congruent angles, so it's going to have the properties of both rhombus and a rectangle. So pause there if you need to copy any of that information. If not, continue on. Let's take a look at some of the questions asked from us. These are the ones I assigned you, so you can double check over your answers. Many of you, when you were answering these questions, just said true or false, but the question didn't ask for true or false. It said sometimes true, always true, or never true. So make sure you are able to quantify if it sometimes is true but not always true, or if it's just never true, never going to happen. So first question we have is, the consecutive angles of a rectangle are congruent and supplementary. All right, well that is always true because a rectangle means four congruent angles, so of course consecutive angles will be congruent, and then because it's also, a rectangle is also a parallelogram, that means consecutive angles are supplementary. So that's always true. Second question, the diagonals of a rectangle bisect each other. All right, that is only sometimes true. The diagonals bisect rhombuses. So if your rectangle is a square, it's going to have the characteristics of the rhombus, so that means that sometimes the angles will be bisected by the diagonals. But if it's a normal rectangle, or what we think of as a normal rectangle, where one set of the parallel sides is a little bit longer than the other set, then the diagonal is not going to evenly bisect the angles. Now I know it looks like on my picture it does, but that's because I'm not that good of an artist. So that is only sometimes true. All right, a rhombus is a square. Again, this is another example where that is sometimes true. If the rhombus has four congruent angles, then yeah, it's a square. But if it's a rhombus where it's just kind of tilted to its side like that, then obviously that's not a square because it doesn't have the four congruent angles, the four right angles. So sometimes true. That does not look like an S. A diagonal divides a square into two isosceles right triangles. All right, so if we have a square and we have a diagonal, well, we know that the angles have been bisected because that's the characteristic of the rhombus, and we know that the sides are all congruent to each other. So yeah, we've created two isosceles triangles. So that is always true. All right, so hopefully you've had a chance to proof over your homework and see where you got those correct or corrections to be made. All right, let's take a look at a couple more examples. I didn't erase the answer in this one. Sometimes I do, sometimes I don't. Whatever, you can see it. PARL is a parallelogram, so it is the measure of y. So this is where in the previous lesson I was trying to talk about the consecutive angles, but here we can see if I have one angle and I have the consecutive angle, I know that the sum of them will be 180 degrees. So all I need to do is set that equation equal to 180 degrees. So 48 plus 95 plus y, since that's the second angle, is equal to 180 degrees. Since I'm adding everything, I can just drop it and then solve for y. And you can see that y is equal to 37 degrees. Pretty easy to set up. The next question says, is tile, T-I-L-E, a parallelogram? And if it is, why is that so? Okay, well, we can tell by looking at the picture that the diagonals are congruent to each other. So using the converse of the parallelogram diagonals conjecture, that states that the diagonals of a parallelogram bisect each other, then we can say that it's a parallelogram. We can also prove using the distance formula that this side is congruent to this side, and this side, and this side. So all four sides are congruent, meaning it's a rhombus. And of course, a rhombus is